All right, everyone, let's go ahead and start talking about density. Now, density, it is an intensive physical property. Now, we actually haven't talked about intensive properties, but I'm going to explain what that is in a moment. But essentially, density is an intensive physical property that relates the ratio of mass to volume. Now, I know that it says remember, intensive properties means whatever, but you actually can't remember it because we have not learned that. So intensive physical properties are properties that stay the same no matter the quantity that you have. For example, this is black. If I were to break it in half and get rid of half of it, it is still black. This piece of paper is white. If I were to rip it, get rid of half of it, it's still white. So if you have a little bit or a lot of it, it stays the same. And density is a property that's like that. And so if you think about a rock is a very dense material compared to, maybe you or I or water. And so if we throw a rock in the water, it's going to sink because it has a high density. However, if you break the rock in half and get rid of half of it, it still is going to sink because it's got the same density. And so no matter how much of something you have, the density will not change. Now, the units for density are typically, for this class, grams per milliliter or grams per centimeter cubed. Now what I'm going to let you know is that these units are actually the same exact unit because a milliliter is equal to a centimeter cubed. They happen to be the same unit. And so those two units, grams per milliliter or grams per centimeter cubed, those are both the same unit. Now density can be used to help identify a substance, since it is an intensive physical property. And again, that just means that if you have a little bit or a lot of it, it stays the same. For example, a lot of people, when they're purchasing silver, if they're purchasing a silver coin and they want to know if it's real or fake, they'll actually figure out the density of it, even if it's a big piece of silver or a little piece of silver, to help them determine if it's fake or not. Because if the density is off, then they know it's fake. Same thing with gold. Now, an object will float if its density is less than the density of the fluid that it's placed in. And so if you have a fluid and you put something in it, the object will float if its density is less than the fluid itself. Now typically we think about water when we're thinking about putting if something sinks or floats. And so we're going to talk about specifically water for a moment. The density of water is 1 gram per milliliter. It's exactly 1 gram per milliliter, which is not a coincidence because we use water to define a lot of our units. Now objects with densities less than 1 will float. And so if something has a density less than 1, it'll float in specifically water. All right, let's go ahead and take a look at this next chart here. And there's a couple cool things that I want to point out. If you take a look at the top of the screen here, which is in your notes, you'll see the picture of the particle diagram that shows low density versus high density. Now you'll see that the particle, the one on the left has fewer particles and the one on the right has a lot more particles. So what that means is that since the one on the right is more compact and there's a lot more particles in there, that means it has a greater density. And we think about this with people also. We think of places like New York having a large population density, and places like Western Texas has a low population density. And so that is another way of thinking of density. It's how much matter is packed in a certain amount of volume. Now the equation is below here. Density is mass divided by volume. And just a quick little interesting fact here. Take a look at mercury. First off, mercury is what state of matter? It happens to be a liquid. In fact, it's one of the few metals that's liquid at room temperature. Now, mercury has a density of 13.55. That's compared to water, which has a density of 1. So mercury is it's more than 13 times denser than water. And just an interesting fact, if you were to take a piece of copper, let's say, or a piece of aluminum and put it inside of mercury, notice how the density is less than mercury, so it actually would float. If you put a piece of copper in mercury, it would float. In fact, if you put an anvil, which is made of iron, inside of mercury, it would float. And we'll go even further. If you drive a car into mercury, into a lake of mercury, it would float. Very bizarre stuff. All right, so density, high density means that there is a lot of mass in a small amount of volume. So if you have a small amount of volume, you have a lot of mass. Low density means you have a little bit of mass in a large volume. And so you have a small amount of mass inside of a large volume. Gases tend to have very, very low density, as you can see on the chart there. Solids tend to have high density and liquids tend to be in the middle, although there are some exceptions, obviously, for example, mercury. So let's go ahead and take a look at some practice problems. Now, the first practice problem here says, what is the density of a block of marble that occupies 287 cubic centimeters and has a mass of 869 grams? Now, what are these numbers here? This number right here is a mass. And the reason why we know that is there's two reasons that we know that. First off, it literally says mass. It literally says it. Secondly, it gives us the units grams. Mass has a unit of grams. Now, what about this number here? Well, this number is a volume. And there's, again, two ways of us knowing. It says the word occupies. The word occupies implies that it's taking up some amount of space, which that's what volume is. For example, like I'm occupying this right here, and my volume is whatever amount of space I'm occupying. The other way we know is the units are centimeters cubed. So the units for volume are centimeters cubed. So those are the two ways that we know that that is volume. Now, what is it asking for? It's asking for the density. It says, what is the density? And so we know that density is equal to mass divided by volume. And all we need to do is take our mass, plug it into there, take our volume, plug it into there, and then we would be able to solve for density. And so let's go ahead and do that. So density is equal to the mass, which is 869 grams, divided by the volume, which is 287 centimeters cubed. And then you plug that into your handy dandy calculator, and we will go ahead and get our answer. Now for this class, what we're going to do is we're always going to write our answer to 2 decimal places. And so I'm going to go ahead and show you. This is what the calculator shows. Zoom in there if you want, if you can. And I'm going to go ahead and put that in there to 2 decimal places. Now, the other thing we want to do is we need to write the units. And so the units are grams per centimeter cubed. And there's 2 ways that we know that. First off, we look at our notes. Oh, look, there it is. Our notes say that the units are grams per centimeter cubed. The other way we know that is look at the equation here. Look at this. It says grams over centimeters cubed. Right there tells us the units because we took our grams and we divided it by our centimeters cubed, and that's how we got these right here. And so that's how you get that. All right, so let's go ahead and go to number 2. A piece of wood that measures 3 centimeters by 6 centimeters by 4 centimeters has a mass of 80 grams. What is the density of that wood? And so we know that volume is equal to length times width times height, and we have a length, a width, and a height. And so all we need to do is take this and multiply them together, because we know it's length times width times height, to get the volume. And this is going to give us 72 centimeters cubed. You can go ahead and pause the video, type it into your calculator to see if you can get that. Now that we have the volume, we also are given the mass here, and so we can take that to figure out the density. So we know density is equal to mass divided by volume. And so all we do is take the mass, which is 80.0 grams, divide it by the 72 centimeters cubed, type that into our handy dandy calculator, and the calculator will end up giving you, with 2 decimal places, 1.11. And again, what are the units? Well, the units are grams over centimeters cubed. And that's it. Also, I forgot to do this on the first one, and that could just be the fact that I'm not doing this in class right now, but I always like you to box your answers, all right? So we're going to box our answers so that we can see where everything is, and then we always want to put a smiley face because we're happy to be here doing these problems. And so here we go, smiley face, mix them up a little bit, and yeah, there we go. All right, so will this piece of wood float? So the wood from number 2, will it float? Well, water has a density of 1. And the way you know that is you look at your notes, and because it has a density of 1, that's the density of water, when we put this wood that has a density of 1.11 in the water, will it float? And the answer is no, it will not float. No, it will actually sink, because the density of the wood is greater than that of the water. And that's the reason why. So again, if there's ever a point in which you need to pause the video to catch up on maybe writing something down, definitely do that. But I am going to go ahead and move through these videos a little bit quickly sometimes. Not super quickly, but just enough so that you're not spending a ton of time outside of class writing some of this stuff down. So feel free to pause the video if you want, or rewind and watch it. But let's go ahead and talk about this last problem here. We're going to look at situation A, B, and C. Now it does say discuss with your table partner which block in each setup below has a higher density, but obviously we're not at school to talk to our table partners. So let's go ahead and take a look at this together, and if you want to, you can maybe pause the video to try to answer it on your own. So let's take a look. Between this block and this block, which one has a larger density? And so what I'm going to do is I'm going to put an equation sign here, or not equation, equal sign, and we know that density is mass divided by volume. And so what I'm going to do is I'm going to write mass over volume. Well, how does the mass of the block on the right compare to the mass of the block on the left? Well, because the scale is tilted, the one on the right has a smaller mass. The one on the left is going to have a larger mass, and so it'll have a smaller mass. However, do you see how the one on the right is bigger? Well, it's bigger, meaning that it has a bigger volume. And so whenever you have a smaller number in the numerator, a smaller number in the numerator will cause, I'm going to write this in a different color, will cause the number itself to go down. So it gives you a smaller number. So a smaller number in the numerator gives you a smaller overall number. And a larger number in the denominator gives you also a smaller number as well. So both of those variables, changing the way that they did, will result in a smaller number. So the one with the higher density is this one, because not only does it have a greater mass, but it has a smaller volume. It has a greater mass and a smaller volume. Now let's go ahead and take a look at the next situation. And I'm going to go with purple this time. All right, so we have mass over volume is equal to, well, notice their volumes. Their volumes look the same. However, the mass of the one on the right is much bigger. So that alone will cause the density to be greater. And so because it has a greater mass with the same volume, this one is going to be the one with a greater density. All right, last one here. This one's a little bit tricky, and so let's go ahead and see what we can do to try to understand this last one here. Now, let's go ahead and talk about how does the cube on the right compare to the cube on the left. Well, the mass of it is smaller, so we have a smaller mass, but we also have a smaller volume. When you have a smaller mass, in other words, when you have a smaller numerator, it makes the number go down. But when you have a smaller denominator, and in this situation we have a smaller volume, it makes the number go up, because a smaller denominator makes it go up. So do you see how having a smaller mass makes it go down, but then having a smaller volume makes it go up? Well, in this situation, it actually could be the case where it balances out, resulting in them having the same density. They could have the same density. But we actually can't make that statement because we don't have enough information to for sure know. So for this one, we're just going to go like this. We don't have enough information to know. And that's all there is to density. I hope you guys enjoyed this video, and you guys have a great day.